Hello friends, welcome to the Cool Chemistry Show. Today we're going to show you about physical and chemical properties through cool chemistry demonstrations.
Before going into this, we must know one thing. Safety always comes first. These things should be only tried by professionals. Do not try this at home.
Proper safety equipment may include goggles, gloves, fire extinguisher, and a fire blanket.
There are two kind of properties, chemical properties and physical properties. First, we are going to show you physical properties. Physical properties are anything that can be changed with a measurable value. The physical properties we are going to show you are taste, heat conductivity, solubility, malleability, and density.
There are two types of physical properties. There are extensive and intensive physical properties. Extensive physical properties depend on the amount of substance present. These things include mass, weight, volume, and length, while intensive properties do not depend on the amount of substances present, such as density, boiling point, and melting point.
The first physical property is taste. For example, if I bit into this lemon, I would experience an observed taste.
Make sure we have our safety goggles on.
All right. Oh, that is sodium sour.
Volume is an extensive physical property. For example, this bucket has about 1.763 gallons of water. Now it has 0.
Now we have covered extensive physical properties, but we are going to talk about intensive physical properties next. Intensive physical properties are not dependent on the amount of the substance present. Some examples of this include density, boiling point, and melting point, to name a few. Another example of an intensive physical property is density. Notice how my pet rock, Jimmy, sinks. That is because Jimmy is more dense than the water is.
One way that energy is given off is through the transfer of heat. For example, if I held this balloon over this hot fire, the heat from the fire would be transferred to the balloon, causing the molecules to expand and then therefore burst. Like so.
Have you ever wondered where the sugar goes when you mix it in water? The reason this happens is because the ions in water break apart the sugar molecules, and the sugar is soluble in water.
Now we are going to move on to chemical properties. Chemical properties are observed with the reaction when the chemical composition or identity of a substance is changed. Another way to think of this is that oftentimes the chemical properties that change cannot be undone, and some of these consist of oxidation, combustion, and the ability to react.
Remember, do not mix any chemicals that you're not sure how they react until instructed by a teacher to do so. Always wear proper attire, wear safety goggles, don't be stupid, and use common sense. So let's goggle eyes, and go. This piece of metal here is experiencing oxidation, otherwise known as rust. This metal is changing into iron oxide, or Fe2O3. This occurs as a result of the water combining with the air and the metal. The water breaks down into oxygen and hydrogen ions, and it then rusts when the oxygen comes in contact with the iron metal. This creates a deterioration, which can be seen as a color change as well in the substance. Vanille, why don't you zoom in on this fine piece of rust?
Another way that we can see chemical properties is through chemical reactions themselves. The chemical reaction we are going to show you happens to be one that is between an acid and a base. HC2H3O2, also known as acetic acid, is a key component of vinegar. Baking soda, also known as NaHCO3, is the base in the reaction.
Property we're going to show you is the ability to burn, also known as combustion. In case this combustion gets out of hand, we have this safety water here to put the fire out. Let's just say we don't like this chemistry notebook because it kind of ruined our lives.
Who would ever think that?
This This is all hypothetical, of course. This match, coated with potassium chlorate and sulfur, ignites with friction on the box. Let's see how the combustion works on the notebook.